In this video, we'll be going over the bottom-up 2D approach of dungeon game. So let's go over the thought process. So let's convert the top-down memorization approach to a bottom-up approach. Now, where do we start? In the memorization approach, we have cached the current cell RC with the minimum amount of HP the knight should have. The knight can have. Which would denote as min health. This means we can create a 2D matrix min health to keep track of the minimal amount of health for all combinations of RC. Now let's go over the pseudocode. So we're going to create a 2D matrix min health. The rows represent R. The columns represent C. And the values represent min health. Now let's denote Mn as the number of rows and columns. Then when it iterates through from M to 0, the rows denoted as R, iterate through the columns from N to 0, denoted as C. Now, if RC is equal to n minus 1 n, or RC is equal to m and n minus 1, this is the cell currently over here. After we have saved the princess. After we have saved the princess, the knight should have a minimum amount of health of 1 in order to stay alive. So I want to set min health RC to 1. Then we can continue to the next iteration. Now if RC is out of bound, or if R is greater than or equal to M, or C is greater than or equal to n, this means our current cell is out of bound. We do not want the knight to step on this cell, so the minimum amount of health we're going to set to a very large value, which is integer.max value. Then we can continue to the next iteration. Now at each of the cells, we have two choices. We can either go rightward or go downward. We want to set minimum health to the smaller value between the two choices. So set min health to the smaller value between min health C plus 1, this is going rightward, and also R plus 1, which is going downward. Now in order to account for the current cell, decrement min health RC by dungeon RC. This basically increases the amount of health that we have lost at the current cell, or decrease the amount of HP we have gotten. So basically, if the current cell decreases our current HP, we're going to increase it back. If the current cell increases our HP, we're going to decrease it. Just going in the opposite direction. Now, if min health is less than or equal to 0, this means any positive value will allow our knight to survive. So we will want to pick the smallest positive value possible, which is 1. So I'm going to set min health to 1. Now we want to return the minimum health of the knight. We start from the top left corner, so 0, 0. Now let's go over the time and space complexity. For the time complexity is O of Mn, where Mn are the number of rows and columns. This is because of our nested for loops. And our space complexity is also Mn. This is our min health matrix. Now let's go over the code. So we're going to create two variables to indicate the number of rows and columns, which is our Mn. Then we want to create our 2D matrix, min health, to keep track of the minimum health for all possible combinations of RC. Then when iterate through the rows, Want to iterate through the columns. Now we'll first go over our base case. The first one is if we save the princess. So after we save the princess, the HP of the knight should be equal to 1. So I want to set min health RC to 1. Then we can continue to next iteration. Now if R is greater than or equal to 0, or M, or C is greater than or equal to 0, or C is greater than or equal to N, this means the current cell is out of bound. We want to set the min health to integer.max value. Then we can continue to the next iteration. Now for the current cell, we have two choices, going rightward or going downward. We want to pick the minimum value between the two choices. Going rightward and going downward. And then to account for the current cell, we need to decrement it by the dungeon RC. Now if min health is less than or equal to 0, we can just pick a positive value. So we'll just say min health RC to the smallest positive value, which is 1. Then we can return the minimum health. We start from the top left corner. Let me know if any questions in the comment section below.